In this video, I'm going to talk about linear equations, but before I do, I'm going to introduce you to the Cartesian coordinate system. And I'm pretty sure that there's a lot of you people out there that have never heard of the Cartesian coordinate system. And that's probably because you've never heard the word Cartesian before in your entire life. Where did that word come from? Well, we have to go back to a French mathematician and philosopher named René Descartes. Okay, he was a French 17th century French mathematician and philosopher. Okay, now the thing is that in France his name is Descartes, but if you were to use the Latin form of his name, you would be using the word Cartesian. So in Latin you have Cartesian, and in French you have Descartes. So realistically, the Cartesian coordinate system is named after René Descartes. And if they'd had it his way, he probably would have called it the Descartes coordinate system, but that would have been a little bit harder to pronounce, so they used the Cartesian coordinate system. Anyway, what is his coordinate system? Well, he has two axes. This one is the horizontal axis, otherwise known as the x-axis, and this is the vertical axis, otherwise known as the y-axis. Alright, why do we even have something like this? Because of equations just like this. Y equals 2x plus 6. Well, we can start substituting numbers for x, and as soon as we do and multiply that number by 2 and then add 6, then we get another number for y. Okay? So let's do this for the number 0. 2 times 0 is 0, and 0 plus 6 is 6. So we graph this answer. Well, here is the 0 coordinate right here, and what we're going to do is we're going to plot a point at the 6 here on the y-axis. Okay, now the first question that might come to some of you people's minds is, why do we call this the horizontal axis and call this the vertical axis? Well, that's because things drop vertically, and they can actually drop into the horizon. Take, for instance, the sun. The sun drops vertically and then sinks into the horizon. Well, the horizon is horizontal, and of course anything that drops vertically. Okay, but let's get back to this. If the x answer is 0, then the y answer is 6. Well, what happens if we put a 1 here? Well, 2 times 1 is 2, and 6 plus 2 is 8. So we plot another point here, and now we have 6 and 8. Alright, now we start putting other numbers in here. X is 2, 2 times 2 is 4, plus 6 is 10. So on and so forth. And we plot all of these points. And then we draw a straight line through every single one of these points. And when we do, we can then figure out the answer to what happens when you put a number here and then you solve the equation. And we can go on and on with this. If you were to put -1 in here, you'd have -2, because -1 times 2 is -2, plus 6 would be 4, so on and so forth. And so therefore you draw this line, and you will see all the possible answers, whichever ones you're going to put in for x, what the answer for y is going to be. And that way you can figure out a coordinate system. Now what you have here is an ordered pair. If you have the number 0 for x, you end up with the number 6 for y. That's an ordered pair. And you end up with a whole mess of these ordered pairs. And you can do this for all kinds of equations, as long as you have x plus or multiplied or divided or subtracted something else equaling y. Actually, you can have an ordered pair if you have x equaling y. Well, if you have x equal y, then 1 equals 1, 2 equals 2, 3 equals 3, so on and so forth. for each answer x, there is another answer for y. And you can plot that ordered pair coordinates on the Cartesian coordinate system, which is this right here. Alright, I hope I didn't confuse you too much. I've actually introduced you to a couple of new terms, and I will talk about more in a future video, so stay tuned.